I've had you make a piece of paper with the numbers 2 through 12 across the bottom of it. I'm going to be rolling 2 dice. And whatever I roll, you're going to be able to take a penny off of that spot. So you're going to put your pennies out on the board right now. And you're going to put them out any way you want to that makes sense to you. So that when I roll a die, let's say I roll a 3, you won't be able to take all the 3s off, but you'll be able to take off a 3. So put your pennies out in a way so that you can get rid of these pennies as quick as possible. You're trying to get rid of all your pennies. If you get all your pennies off the board before anybody else, you will win a chance to reach into the bag of mystery and wonder in here, which has lots of candy in it still. Replenish the supply. What? I'm gonna roll this probably 12 times before somebody will win. I'm going to roll 2 dice. That's why it goes up to 12. Otherwise, yeah. What? Yes, so when I roll the 2 dice, let's say a 3 and a 2 comes up, then I will say 5, and then you will take off the 5. Okay? All right. Now I'm seeing different strategies. Some people are spreading them out. Some people are piling them up. Some people are betting on a certain number. All right, let's see how it works. Here is our first number. It's an 8. So now I'm going to make a little circle here. Just one of the pennies. Just 1 8. I did say it clearly because I knew that would be an important point. You can only take off 1. Oh. All right. I'm going to keep track of what we get. So we had 1 8. Okay, here we go. 6. Take off a 6. Next up, 7, lucky 7. Now, what was I saying about the middle before? What was I saying about the middle? You remember what I was saying about the middle? Now, people tend to like the middle, and so far that's working pretty well for you if you pick numbers in the middle. If you have them all on 8s, you had them all on 8s. Deal with it. If you're going to play the game multiple times, you'll probably lose this one. Although I did roll 7 like 33 times last hour, so. All right. 12. Next up, 10. Those of you that spread them out are starting to look smarter now. 6. 6 has come up twice. Interesting. Next up is 9. The spread it out people and the ones that were on the high end are probably looking smarter right now. 5. 6 again. Did anybody have 3 6s? Ooh, you're looking pretty smart right now. Sure. All right. 4. Next up, we get a 6. Holy cow, we're getting a plethora of 6s. 4 again. 8. Oh, we got a winner? All right, we have our first winner. Okay, now rearrange your board. Come on up if you'd like to grab out of the bag of mystery and wonder. Now, put them out again. And now, think about a smart way to do it. Now, really, you don't want to do necessarily, if you look over at your friend and he's doing it a certain way, you don't really want to necessarily do it the same exact way. Yes, go ahead. Yep. All right, finish in the next 20 seconds. All right, here we go. 9. 9. 7, lucky 7. Five. Niner, 49. 6. 6 has been hot. 7, lucky 7. At a casino, they make money on this process. 3. Because what they're betting on is that people don't understand probabilities too well. 10. A lot of people use superstitions and stuff at the casino, and the casino just trusts that because they know that they've got it set so they have a little edge. We'll talk about how to do that in just a second. 10. 7, lucky 7. 5. 9. 5. 11. Did anybody even have an 11? Ah, several of you did. Spread it out. All right, next one's a 7, lucky 7. 10. 8. Anybody getting close? All right, a lot of people getting close. 7, lucky 7. All right, let's pause and talk about it for a second. We're not done yet. I know there's people that are close, but so do you notice that they are tending towards the middle? Does it have to do with the weight of the dice? No. The combinations that you can get. Yes, let me give you an example. If I roll one of the dice, just one of the dice, do you get how I'll never get past 6? All right, 6 is the most you can get. Okay, but if I roll a die, do you get that how no matter what, when I roll a second dice here, I can still get a 7. You see what I mean? I can still get a 7 no matter how the first number comes up. I can still get 7. Okay, but there's a lot of things that are ruled out. If I get a 6 right now, I can't possibly have a total of 1, 2, 3, 4, or 5. See what I mean? Okay. Now another way to think of it is that there's just a lot of things that make a 7. Like what? 3 and a 4, 4 and 3. Why do we reverse them? Think of them as two different colored dice. If I roll a 4 on the white die and a 3 on the blue die, that's a total of 7. If I roll a 3 on the white, what did I say? If I do it the other way, that also is 7, and it's different because they're different colored dice because there's 2 dice involved. All right, so I'm going to keep rolling. Get back to the game. 6. Have any winners? All right, 2 winners, 3 winners. Come on up. Grab out of the bag. We'll do one more. Put them any way you want to. Now, there's a thing called the law of large numbers, and it says that if you do an experiment long enough, eventually it'll come out very close to the theoretical probability. Do you get that theoretically 7 should come up the most? All right. But after only rolling 4 or 5 times, you couldn't see that pattern. But can you see it now? Because I've got a lot of discs up there. All right, so you can sort of see that the middle is most popular. What's the least popular? 2 and 12. Why? Because you have to have either a 1 and a 1 or a 6 and a 6, and those are hard to get. All right, specifically, if I take just a second and wipe all these off, And then I go, okay, 2. Then I'm going to go 4 and 3, 3 and 4. What else makes a 7? 5 and 2, or 2 and 5. 6 and 1, and 1 and 6. Can't subtract. No. Okay. And let's do one kind of along the way to it. How about the 4? How many ways to make a 4? Well, 2 and 2, 1 and 3, 3 and 1. See how it's half as many? Well, okay, how about a 2? How many ways to make a 2? 1 and 1. If I actually got a 12, it would be what? 6 and 6. So then, if you look at this little pattern here, that's a bell-shaped curve. It's the bell curve. There's a lot of things that tend towards the middle. Shoe size, for example. Do you think there's a lot of people that have size 12 shoes? No. Many people have size 12 shoes. Okay, do you think many people have size 2 shoes? No. Do you think a lot of people are kind of in the middle? Have average size. Now, for shoes, the average is not right in the middle at 7. Okay, but just think for a second. We'll just use men's and women's sizes, even though they're different. We'll just use whatever your size is. How many of you are a size, which is, I think, pretty common, like a 7 or an 8? How many of you are a 7 or an 8? Raise your hand if you're a 7 or an 8. Okay, how many of you are a 9 or a 10? Ooh, that one was probably a little more popular. How about 10 or 11? How about 11 or 12? How about 12 or 13? How about 13 or 14? Anybody bigger than 14? Every now and then there's a kid with giant feet. All right. How about we'll go the other way? Size 6 shoes? Size 5 shoes? Size 4 shoes? Anybody smaller than that? Okay. No. All right. So, I think it was between an 8 or a 9 for your class. Do you think that answer would be different in a foreign country? Possible. Yeah. Okay. You can imagine heights would also be different in different countries. We're kind of a melting pot here in the United States. In this classroom, we're not terribly diverse, but still diverse as far as, like, most of you guys are not pure Norwegian or pure British or pure. Are you actually pure? Are you a purebred? Even you're not purebred. So, for those of you that are, is there anybody here who's purebred something? Like you're pure Norwegian or almost pure? How about almost pure? Almost pure what? Irish. Cool. Yes. Cool. Anybody else that's close? All right. Then you can console yourself. You're like me then. I'm a mutt. And there's something called hybrid vigor. And it means that if you're a hybrid, if you're a mix of two kinds, then you're stronger a lot of times than the purebred. Okay? There is hybrid vigor. I'll give you an example in cats. Cats that are purebred are not as healthy. They don't live as long as ones that are crossed with something else. There's something called hybrid vigor. So you got that going for you. All right. So there's a tendency towards the middle. 7 is probably the thing that should come up the most, but knowing that, you still aren't going to automatically win because there are some things like that 8. I'm going to go back to what we had before. Do you notice that the 8 was like tragically behind the others? The 8 should have 2 or 3 more by now, but it just doesn't. It's just having an unlucky day. Just like last hour, I had so many 7s I couldn't even like make them fit. I had to stack like they went all the way to the top of the screen and went 4 more than that. But sometimes things get lucky. Okay, and that's where people can win at the casino. When they get lucky and it happens to come up the thing that they wanted, it happens to come up. So that's why people go home from the casino and say, I won lots of money, and that makes other people want to go to the casino. Because if, on average, people lose $50 at the casino, that's why they tempt you to come in with like free money and like really cheap buffets and that kind of stuff, so that they can get you in the door. The average person will lose $50. Does that mean everybody loses $50 every time? It's an average. So some people win 250, some people lose 350, and it averages out to losing 50 on average. All right. And if you can count cards, that's a good one. It comes up in movies a lot. You can actually get a little edge on the casino, so they don't want you to count cards. Counting cards, it's not illegal. They can, but it's their right to throw you out for doing it. But that's different than illegal. Okay, so a person can try to count cards, as in like keep track of what cards have come out on the table, and therefore give yourself a small mathematical edge. It's very difficult to do in real life, and if they catch you doing it, they will kick you out because they know that you're going to get a small advantage over them by doing it. Okay, so they watch for certain things. They watch for people that all of a sudden start increasing their bets a lot. Because that's what you do is if you know that you got to keep playing the whole time. You can't just sit out until the deck looks really good and then start playing. Okay, because then they'll for sure kick you out. But if you're playing the game and all of a sudden people are like, oh, they're increasing their bets and then they're winning when they increase their bets, those are people that are probably counting cards. So if you're ever playing with somebody and they're like betting the same thing every time, they're not counting cards. But if they're betting a lot more all of a sudden, it's because they think the deck is right, as in it's got lots of big cards in it, which means the dealer is more likely to bust when you play casino. Okay, so that's why people are sometimes bet a lot more because they think the cards are really good. Yes. There are lots of strategies if you're counting cards to try to not stand out as a card counter, because if you get caught as a card counter, then they put your name on the blacklist, and then whenever you come in, they just say, oh, you can't play. In fact, they even have face recognition software now, so that if you walk into their casino, they'll like have people walk right up to you and say, oh, it's time for you to go. Because they recognize you as a card counter, and now you're marked, because they know you will take their money away instead of lose money. It's not illegal, remember. It's different. How can they kick you off? Because it's their place. It'd be sort of like if you go into the Chinese buffet and eat like 400 pounds of food. The Chinese buffet place can say, you're out of here. Because it's their place. Because you eat too much. You go home now. All right. Anyway, let's go a little further here. All right, have you replaced your stuff? All right, one more, except this one I'm going broke on candy, so it's going to have to be the most unpopular kind of candy. The winners of this one can only get chocolate Laffy Taffy. It's not that bad, but it's not the best. I know you'd pick something else, so. All right, I got to get rid of it somehow. All right, here we go. One more time. Everybody got their chips placed? All right, here we go. 8. Take off an 8. Look at that. We needed an 8 to fill out our pattern. This is called the law of large numbers. If I do this long enough, this is a 5. It will come closer and closer to what it should be. Here's a 4. Next one is a 6. Now, one thing though, let's say that there was one that was really low. Next one's a 9. Like 8 was a little low for what it should be. You can't just bet a lot on 8 because it's due. That's another human tendency to say, like, let's say you were flipping a coin and you get heads, 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 and doesn't it seem like the next one's got to be tails because it's been heads so many times? So don't get confused that the law of large numbers says that, like, the forces of nature are going to come in and make that coin next time have to be a tails because I've bet heads so many times. Nope, still a 50-50 chance. All right. Next one is 6. 6 is getting unnaturally lucky. Shouldn't be beating 7, but it is. 6 again. 8. 10. 9. 10. 6. 6 are getting insanely lucky here. 10. 10s are coming up way too much too. It's just the way it is. That's randomness. 7. That'll help some of you. Oh, we've got a winner. All right. We'll go for one more just because that was pretty early. I got 3 more pieces of chocolate Laffy Taffy to get rid of. Here we go. Save. Not another game. Whatever you had left, put it back out there. 10. 9. 5. 6. Oh, there it is. All right. Go. All right. That's it for that. Now, you can set that aside for now. I'll get the pennies back from you later. All right. Let's just talk through these quick. I don't like just, making you write down definitions and stuff, but it is important for you to understand what random means. No individual outcome is predictable. Even though a long-range pattern is predictable. In other words, I could have predicted that most would be kind of in the middle, and they were. But I couldn't predict exactly which one would get lucky, like 6 got crazy lucky. Couldn't predict that. All right, let's talk about this again in terms of what happened for us. Event. That was every time I rolled the dice. That was an event. Sample space. You would have never known what the heck that was. It is the set of possible outcomes of a random process. So, for instance, when you're rolling a die, the sample space is 1, 2, 3, 4, 5, or 6. That's when you're rolling one die. Those are the things that can happen. This is an important one here. There are 36 things that can happen when you roll 2 dice. 6 on this die, 6 on that die, and you multiply it. 6 times 6, 36. There are 36 things that can happen. And we showed you how you could make a 7 by, there was actually 6 different ways to make a 7. And that's the most common one. So that's a 6 out of 36, or 1 in 6 chance you'll roll a 7. Yes. Okay, moving on. Experimental probability versus theoretical probability. Theoretically, on this coin here, what do you think is the probability I will flip a head? 50%. But if I actually flip the coin only once, can you see that probability? No. But if I do it a whole bunch of times in an experiment, what happens if I do an experiment and I flip it 100 times and it comes up heads every time? Are you going to start getting suspicious that there's something wrong with my coin? You should. In fact, I remember a probability professor I had in college who said, if it comes up red, there's red and black on a casino. If it comes up red 5 times in a row, you shouldn't be betting on black. In fact, you should go start betting on red because it's already come up 5 times in a row. The machine's probably broken, or somehow there's something causing it to come up more often. It's not likely, if anything, it's not likely that we're going to get another 8 to fill this hole in. That's people's tendencies to think that. You should actually be thinking, maybe there's something wrong with my dice, and bet on 6 because they're coming up so much. You see what I'm saying? It's not likely that it's going to go the other way on any one individual trial. It's more likely something's broken to cause 6 to be higher than 7. That's messed up. All right, moving on. How do they make money? They make it on a small percent. So on blackjack, for instance, they make an average of about 1.5%, maybe 2%. On each bet. So they have a tiny edge on you. And you can fix that by counting cards, but it's very, very hard to do. People think it's easy. And if you only have one deck, it is kind of easy. So what do the casinos do? They mix together 6 decks at a time. So that it's much, much harder to count cards. There are some places in downtown Las Vegas that will still do 1 deck or 2 decks. Okay, and those are much more likely, but they also are much lower limit tables. Like, they won't let you bet very much at those tables because they know that there's a higher probability card counters could use that. So, all right, moving on. The law of large numbers says that the more times you do something, the closer you will get to the theoretical average. In other words, if I flip a coin 1,000 times, you get it's probably going to be pretty close to 50-50. But if I only flip it twice, not great chance that it's going to come up exactly. So the more you do it, the closer you get. All right, contingency tables. This is a contingency table on left-handed and right-handed people. I always think it's more fun if we do the contingency table for this way. iPod, or no iPhone, and this is no iPhone. and this is dog and no dog. Alright. And then we need totals at the end. So let's do this in the class quick. How many of you have an iPhone? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Just so you know, that's almost exactly the same as last hour. Raise your hand if you have no iPhone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Pretty close to half, but I just did dog and no dog by accident. Oh wait, that was, sorry, there we go, 19 there. Okay, now, I just did iPhone and no iPhone. Now I have to ask the question of dog and no dog. I just screwed that up. I'm just going to stick with iPhone and no iPhone for now. I'm going to ask, I'll show you another chart where you have both. For right now, I'm just going to get my totals here. The total people that had iPhones were, oh, I know how I should ask. Dog, no dog. All right, how many of you, I'm going to change that. How many of you have a dog and an iPhone? Dog and an iPhone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many of you have a no dog but do have an iPhone? You don't have a dog, but you do have an iPhone. 1, 2 of you. All right. How many of you have... that's okay. Those are just total of people. The total is 13 people. Oh, wait. I might have screwed up. In fact, I remember I want to name the individual, but if they had their hand like halfway up, I think they were trying to ask me a question instead of saying they had an iPhone. That's fine. Sorry about that. All right. Back to no phone and dog. Who's got no phone, no iPhone, but does have a dog? No iPhone, but you do have a dog. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. How many of you have no dog and no iPhone? So sad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now, that should represent every person here. Because if you had a dog, or you didn't have a dog, you had an iPhone or you didn't have an iPhone, and at some point you would have had no dog and no iPhone if nothing else. So, okay, so now if I add these all up, I can go 9, 11, 20 here, and that's 20 whats? People with dogs. How about the 2 and they're making it 12, or 2 and the 10 makes it 12. That's 12 people have no dog, okay? And then the 9 and the 10 makes 19 people that do not have an iPhone. Okay, now I got my chart right. So this is called a contingency table. Now here's the easy part. Let's say I say, I'm going to win if I toss this penny behind me and it goes to a person or closest to a person that has no dog and no iPhone. Thank you. I hope I didn't hurt you. No dog and no iPhone. Well, I had 10 people I could have hit like that, right? All right. Are you one of those people? So I didn't win. I had a 10 in what? Chance. Let's add these all up and see what they add up to. The total number of people in this class, 2, 4, 6, 8, 30, 32. 32 people total in this class. And do they actually add up right? Yep, they do. Good. Okay. So there's a 10 in 32 chance that I would have hit somebody, and I didn't. Actually, shouldn't have been, right? The 10 in 32 reduces to about only 1 in 3 chance that I would. But what if I try it 3 times? Who's that closest to over there? All right, so are you a no dog, no iPhone person? Just answer the question. Okay, so I'm looking for the no dog, no iPhone, and who else got it over there? And you're not one of those? All right, so if I do it 3 times, though, I'm fairly likely to hit a person, but I'm not guaranteed. I mean, I could get really unlucky and throw like 6 of them out there and still not find one of these people. All right. Yeah. Now, let's talk. You can add them this way, or you can add them this way. All right, now, I'm going to give you a probability question. I want you to write it on that piece of paper you have out. And I want you to see if you can figure this out. If I randomly tossed a penny to a kid, what's the probability I would get a kid who had an iPhone? Don't say it. Write it on your piece of paper. Probability I would hit a kid who has an iPhone. It's a fraction. If I bias it by which way I throw it, you're right. But if I throw it like over behind my back or something, then hopefully that will keep the bias up. But you're right. If I purposely intend to throw it this way, it throws everything off. Then it's not random. All right. So now, did you say 13 out of 32? All right. So that was 13 and 32 chance. 13 kids had an iPhone. All right. So how about this? I'm going to change the type of question a little bit, see if you can handle this. Given that I only picked out of people that have an iPhone, what's the probability I would get somebody who has a dog? Write this down as a fraction. Given that I'm only picking from people that have an iPhone, what's the probability I would get a kid who has a dog? Who has a dog? 11 out of 13 chance? All right. How about this? If you have a dog, are you more likely to have an iPhone? Is it a huge difference? No. 11 compared to 9. If only one of those people had switched over to no iPhone, then they would have done exactly. Okay, so having a dog doesn't seem to be a strong predictor of having an iPhone. But there is a slight correlation. All right. Yes? Yes, that's true. If you're trying to sell dogs, somebody probably would use that. If you had a dog, you'd be more likely to have an iPhone. Not that having the iPhone is the ultimate. There are phones that are, some people would argue, are better than an iPhone, so it does kind of change the equation. All right, how about this one? I'm going to do an or, and I'll see if you can handle it. I'm going to win if I pick a person who has a dog or an iPhone. I'm going to win. Figure out the probability I'm going to win. I'm going to win if I find a person who has a dog or an iPhone. So really what it comes down to is what you want to win goes on top. What I want over how many were possible. What did I want this time? I wanted people that either had, stuck here. I wanted people that either had a dog. Do these people have a dog? Do these people have a dog? Do these people have, or I could also win if I find a person with an iPhone. Do these people have an iPhone? Would these people have won for me? No, because they don't have what I wanted. They don't have a dog or an iPhone. So I'm going to take them off, and then all of a sudden, what do I do with those three? Those are the ones that would win for me. Where do they go? On the top. 11 plus 9 plus 2, so 22 out of 32. Did anybody have that one right? Raise your hand if you did. Okay, good. So when you say or, you add them together. I win if you get this or this. Like, I'll give you an example. Let's say that I said, I'm going to win either if I get a boy or if I get somebody who's got a dog. You see, as soon as I added that or somebody who's got a dog, I increased my probability. Okay, so I got to add on the top. All right, let's look at geometric probability. The area of the desired region over the area of the total possible region. That's like this. The parachuter is approaching the ground and will be landing on top of a skyscraper. The roof of the skyscraper is a 250-foot square. That means 250 on each side. There's a round pool on the top that is 60 feet across. Picturing all this? Say the pool's right in the middle, 60 feet across. From here to here. What's the probability that he lands in the pool? Well, do you remember how I said it was what you want over what's possible? What we want is to know about the pool. So we want the 60, but it's not an area of 60. How do you get the area of a circle? Pi r squared. So if I use pi r squared, what's the radius on the circle? 30. So 30 squared, can you do it in your head? 900. 900 times about 3 makes about 2,700. That's the area of what I want over what's possible. 250 times 250. Yep. The area, all of this is possible. So 250 times 250, that's pretty big. But we could do 25 times 25. 625. So take 625, add a couple of zeros to it, and it's like that. Then there's my answer. There's my probability. It's what you want over what's possible. Well, 60 foot across, that's pretty big, really. It's just compared to the total of the roof. I mean, it's like a big skyscraper. All right. All right, and if you wanted to generally know, is he likely to hit it or not? Well, not too likely. Although, then there's other things like reality, like if you're the guy who's trying to land on the skyscraper, aren't you going to want to aim more towards the middle? Okay, so we're assuming he's going to randomly hit the top of the skyscraper, but in real life, the guy who's trying to land, the parachuter, he is very likely to be aiming towards the middle because he doesn't want to get to the edge and like almost land on the roof and then fall off. Even though he has a parachute, it doesn't work so good because the parachute deflates and then you start falling, it doesn't automatically re-inflate nicely. It might. So I'd rather land in the pool if it were me and be safe than to try to hit the edge. Yes, those are harder ones. So what you do as an experiment is they have to have a bunch of times where you try it. You probably wouldn't want to do it with a real human, but you do it with like a test dummy, and you make it so that the parachute deflates, and then push the dummy off the side, and then see if the parachute reinflates. You'd experiment, and you could get your probability that way. Okay. If you worked on the very top of a skyscraper, wouldn't it be kind of cool to have a parachute? It seems like it'd be a great gift for people that were, heaven forbid, in 911, when those buildings got hit by and the buildings were on fire. There were people that jumped. I guarantee you, they'd have spent a lot of money to have a parachute at that point. So there were people that jumped. The reason they jumped is because they were faced with an awful choice. They're like being burned, like on one side, and they're like leaning out the window, and they're like, I can't take being burned anymore, or I can't breathe. Like if I don't jump, I'm going to. So they had two choices. It's like, yeah, take the risk, take the chance that you're going to hit something when you hit the ground that's soft enough, like, back like this. All right. If no matter once you don't have to jump out of a very high building to make it pretty much probability it's not high that you're going to live, but there is a chance. I told you about it. You can track if you're up high enough. You can actually track. You can lean side to side and actually you could aim for things. And if you happen to be able to be lucky enough to see, one of those awnings. Have you ever seen awnings that are like made of fabric stick out of buildings? There's a chance you could hit one of those. You'd break through it, yes, but you would slow you down so much that you might end up surviving. piece of fabric that big is a parachute. That saves you, isn't it? Yeah, okay, don't change the topic. All right, so now, your assignment. So right here in Schoology, it's worksheet A and B, but that's a little bit much for an assignment. So worksheet A is pretty easy. So you do all of worksheet A. But worksheet B, if I assigned all of that, that'd be cruel and unusual for the first day back. So I'm going to do odds. Or sorry, skip the odds on worksheet B. You may do just the evens on worksheet B. Okay? So on this one, you may skip odds. Now let's get started together. Open up worksheet A and we'll do the first couple problems. Yes. Oh, you got me. First day back. All right. So here's your worksheet. Get it open on Schoology. Here's A. First question. A national survey is taken measuring the highest level of educational achievement amongst adults aged 30 and older. Express each probability to the nearest 0.001. That means when you're done, like I wouldn't bother in the classroom right now, but when you're at home and you're almost done with this thing, grab a calculator and divide them all, because they're all fraction answers, but they want them as a decimal. Okay, so just take your answers that are fractions and divide them on a calculator quick and write in your decimals. Okay? Now, so part A, let's just do the fraction for it. Find the probability that a randomly chosen person from the survey group is a man. Do you get that there are this many total people? 3172. All right, so it's out of 3172. I recommend you figure out this in two ways to think of it. What you want over all the things that were possible. These are all the things that were possible. And what do you want? You want it to be a man. How many men were there? Because it says that. I want to find out about how many men compared to what was possible. The men was what? Say it if you know. Can't you see where all the men are? 1570. Okay, we'll get to the next one just a minute. All right. So 1570 out of 3172 is your first one, because that's where all the men are out of what's possible. Remember, it's always what you want over what's possible. All right. Next one. Find the probability that the highest level of education completed by a randomly chosen person is a bachelor's degree. All right. Always ask yourself, what do you want? I want the bachelor's degree people. Do you see where the bachelor's degree people are? Which number am I using? 1002, because they didn't specifically say men or women, they just said bachelor's degree. So that's 1002. Over, yeah, anybody was possible. 3172. All right, this next one is different, because it says, find the probability a randomly chosen woman has earned a bachelor's or graduate degree. All right, if I can only pick from the women, only pick from these. Do you get how that changes my problem totally? Focus on what I'm doing right now, please. You shouldn't even be looking at the answer. Okay? Just look at this. So, randomly chosen woman has earned a bachelor's or graduate degree. Where are the women? All the women are in this blue circle. Where are the ones that have a bachelor's or, number one and two, or, you have to add them together. Bachelor's or graduate. Here's the bachelor's, here's the graduate. So it's 539 and the 377 over the total. The total is what you're always going to put on the bottom. All the things that were possible were 1,602 people were possible. All right, so that's C as in cow. Next one, D. Find the probability a randomly chosen person whose highest level of education is high school is a man. All right, so first of all, I got to find the pieces, right? Where are the people where a randomly chosen person whose highest level of education is high school? I'm going to find those people. There. Do you get how I narrow it down to just that? Because they said a randomly chosen person whose highest level of education is high school. Now I'm narrowed down to just that. So then what do I win with? Which of those numbers makes me win? The ones I wanted. Which ones did I want? The 305. So it's 305 over, and since I can only pick from high school graduates, use the total. So since I got to stay in the blue circle, the only total I got is that one right there.